So we continue our brief introduction before jumping into the first chapter. The main functional units of a computer. So when I say functional units of a computer, what I mean is the parts of the computer divided into categories based on the functions they perform. So we have five main functional units: input unit, output unit, memory, ALU and CU. And they are mostly self-explanatory, but I'll give you a brief walkthrough of what they do. The input unit accepts input from the user, converts it to a form understandable by the computer and passes it to the CPU. The output unit takes the output given by the CPU, converts it to human understandable form and either displays it or prints it, or if it's an audio, plays it, whatever. Arithmetic logic unit performs arithmetic and logical operations. Memory is where all your data and instructions are stored. There's a difference between data and instructions, which I will come to in a minute. And the control unit, as the name suggests, controls and coordinates the various actions. So the control unit is what instructs the input unit to receive a piece of input. It is what tells the output unit to display something as the output. It is what tells the ALU to perform an operation. It is what takes data from the memory or writes data onto the memory. So the control unit coordinates all these activities. So those are the five main functional units of the computer. Now, information in a computer can be represented in terms of data and instructions. So data are the operands upon which the instructions operate. So for example, if I have a statement add x comma y, then x and y are my data. Those are the operands on which my addition operation is going to be performed. And the entire statement, which includes the command add as well as the operands x, y, the entire statement is my instruction. So both your data and instructions are stored in your memory. There is no distinction as in this set of address or this set of memory locations are for storing instructions, this set of locations is for data. There is no such distinction in the memory. But when it comes to the registers, the instructions are taken and decoded in a certain way and the data is taken in a certain way. So that distinction comes into place, a minor distinction over there. So for that sake, it is important to understand what's the difference between data and instructions. Data is strictly the operand, only the value on which you perform an operation. And in case of a computer, most of the time it is numbers as in directly digits or any other data which has been converted into numbers. Whether it is a text document or an image, a video, whatever, there are embedding techniques, encoding techniques to convert that data into a series of numbers, and those numbers are what your computer works with. So that is your data. And that those numbers again are a string of zeros and ones, binary digits or bits. And then you have instructions, which is the entire statement, which includes the command, the operation to be performed, as well as the operands. Yeah, so this is just an overview of the main functional units. The input unit, which I explained. So the input unit, it interacts with the memory and the processor. The real world is the user here. So the user gives their inputs to the input unit, which could be your keyboard, mouse, so on. That input either goes to the memory and is stored there, or it is taken to the processor directly for some computation to take place. So this is how the input unit acts as an interface between the user and the rest of the system. Memory is where both your data and instructions are stored. Memory again is made up of bits. A collection of 8 bits is a byte. It is also sometimes called a word, and each memory location has an address. These are things you're familiar with. And then random access memory provides a fixed access time. So there are different types of memory. You have RAM, ROM, you have erasable ROM, programmable ROM, and so on. So in your computer, your main memory is generally RAM, random access memory, meaning irrespective of the address at which your data is stored, the time taken to access the data is the same. For example, irrespective of whether my data is stored at memory address number 1 or 1000 or 10,000 or 5,000 or 50,000, it takes the same time to access. That is why it's called random access memory, and this time taken is called the memory access time. Now in a computer we have different types or different levels of memory. There is a sort of memory hierarchy which starts with your registers, then we have cache, main memory or primary memory, and then we have something known as secondary memory and virtual memory, all of which we will be studying about in this course in subsequent chapters. But for now, when I use the word memory, I am referring to main memory. That's the memory unit. And then we have the ALU, which performs all arithmetic operations and logical operations. Arithmetic is your math, logical operations are your comparisons, greater than, less than, equal to, greater than, equal to, less than, equal to, and so on. And one important factor to be kept in mind about the ALU is it can only work with operands which are taken from the registers. So in your CPU, we will have a diagram. So this is your internal setup of your CPU. Here's the ALU, here's the control unit. These are some special registers which I'll be coming to, and these are your general purpose registers. So now if I want the ALU to perform some arithmetic operation, the operands must be present in these registers. I cannot expect the ALU to take data directly from my main memory and perform operations on them. So the ALU only works with data present in the registers. So if I want an operation to be performed on two variables x and y, and if they are not already present in my registers, they should first be brought from my main memory to the registers, and then the ALU will work with them. So that is something to be kept in mind about the ALU. And then output unit, again, it converts the output given by the CPU to human understandable form and displays it. That's the again the output, again it is either taken from the memory and displayed as such, or some computation has happened, some processing has been done, and the output is given to the output unit, and that is displayed. So that's that. And the control unit controls and coordinates all these functions. It controls what action takes place and when it takes place, in what sequence, and so on. So those are the 5 main functional units of a computer.